Hi, Algebra 2 folks, it's Miss Backfish, and I am going to try and give you a little bit of help on your Delta Math. I'm logged in as a student named second period. This still applies to sixth period, but I'm not positive. I'm not sure enough about how Delta Math works to be able to tell you if the questions I see are going to be the ones you see. I kind of hope not, because if I do it for you, then you're not getting a chance to practice. So if it turns out that it's the same exact problem you see, I would suggest maybe try to get it wrong and see if they can give you other practice problems like it. Because if you get it wrong, it should give you a different problem. I may go ahead and just make you a generic extra practice, optional extra practice with exponential and logarithmic function graphs, Delta Math for you to work on this weekend. So that might be another thing. But just don't just take it the way I did it and say that's, it's been done for me, so I don't care anymore. So this one says, what are the features of the function f of x equals negative log base 3 of x minus 1 graphed below? And it's graphed below. So one of the things I'm posting to your e-class is what was on the board that I kept referring to today that was sort of like your cheat sheet for comparing exponential functions and logs. You might want to have that out. And on that, you should see, remember that for log functions, we have a vertical asymptote. So we're seeing that. We can look at the x-intercept as something we can analyze. We can look at the horizontal shift here where this is being moved right 1. We can look at this negative and say this is flipping it across the x-axis. But really, we don't just need to randomly tell the features. It gives us drop-down menus. So the function f of x is let's see what they want to know. It's logarithmic. It has a log in front of it. So it's a logarithmic function with we just said it's a vertical asymptote of, looks like my asymptote is at x equals 1. I know it looks like it touches 1, but it's impossible to get infinitely close to something without making it look like it touches. So this is not meant to actually touch 1. If it was going to be an x equals 0 asymptote, it would be passing 1, and it would be more in this area too. So I'm going to say x equals, because it's vertical, y equals would be horizontal, 1. The range of the function, range, remember, is all the possible y values. That's all real numbers. So all real numbers is right here. And it is blank on its domain. It is from left to right, it is decreasing on its domain of, the domain is from 1, this is like a wall at 1, all the way to the right forever. So that means from 1 to positive infinity. The end behavior on the left side, that's over here. On the left side, it's going, let's see what they have to say. On the left side, it doesn't go to negative infinity because it has this wall at 1. So it's coming to 1 from the right, and it's going up toward positive infinity in terms of y values. In other words, as we go toward the left, it doesn't pass this, it stops at this asymptote. So it's getting closer and closer and closer to 1, and the y values are going sky high. On the right-hand side, as the x values go toward positive infinity, the y values are going down. It may not be looking like it's going down very fast, but it is going down forever. So x equals positive infinity, y equals negative infinity. Awesome. Another question we can look at. Let me see if I can move the window. There we go. Graphing exponential and log functions. Here we go. Graph the function, and this is exponential because you don't see log, you don't see log, and you don't see ln. So this is an exponential problem. So again, using that cheat sheet, which you might want to use until you can picture everything on it without having to look at it, until it's just starting to feel like instinct. Exponentials have a horizontal asymptote. So my asymptote is horizontal. Great. And any 2 points with whole number coordinates. Okay, so let's think about those 2 points that we have originally. Originally, we always look at the point 0, 1, and the point 1, and then your base. Your base here is 1/2. So 1 1/2 is what I would think. Now, obviously, that's not whole number coordinates. They asked me to do whole numbers, so I guess they won't let me show that. But, all right, I get you. You won't let me show that. Let's think about what happens to those 2 points. This is a vertical stretch by 2. This is a horizontal shift right 7. That's all that's happening. So that means the x values are going to go right 7. All the x values are going to be moved right 7. So 0, 1, x value is going to be 7. So 7, 1 is where that point is. And then the y values are going to get multiplied by 2. So that becomes 7, 2. So 0, 1 becomes 7, 2. Then remember, my next point was 1 1/2. 1, we add 7 to. 1/2, we multiply by 2, and there we have it. Now plotting the asymptote. There it is. So this is kind of cool. I get to move the asymptote up there. Where is the asymptote? Well, let's look. It's a horizontal asymptote. The only thing that moves horizontal asymptotes away from 0, 0, which is where I've got it now, is if there was a vertical shift. There's not a vertical shift. So let me make sure it's as close to 0, 0 onto y equals 0 as I can get it. And that is what my graph should look like. All right, let's try another one. The graph of f of x is solid black below. Which function represents the dotted graph? Okay, well, let's look at what's happened here. It's been scooted to the right. It's been reflected over the x-axis. I think that's it. Okay, I might want to just make sure, if I think that's it, I might want to make sure by thinking about points. Like, for instance, the point 4, 2 is on this graph. If I move right 1 with that, and then flip it over the x-axis, that would be at 5, -2. Yes, I do have a point there. So yeah, it looks like it's been scooted right 1. Now right 1 is happening inside the function, so that means inside the parentheses. So either this one or this one. But remember, horizontal is always opposite of what you would seem to think. You would think that right 1 would be +1. It's -1. And the negative out in front flips it across the x-axis. So that's my answer. And let's see. Transform the solid black function to match the dotted function. Oh, wow. So this is just general transformations, but you can do this. First of all, well, sorry. Do I need to change it to negative? No, because I'm taking this over there. It does not get flipped upside down. It doesn't even get flipped across the the y-axis either. But there definitely does not need to be a negative out front because that would flip it upside down. Flipped across the x-axis would be if this was negative. It's not. I love the way it shows what happens. That's pretty cool. Okay, so this needs to move basically just right and down. Right, like if I wanted to go right, let's say this point. This point needs to go 1, 2, 3, 4, 5, 6 to the right. If I say +6, remember, it's going to go 6. It's not going to show me, is it? Yep, it's going to go 6 to the left. So I need to say -6. The only way I can do that here is say +(-6). And then I just need to move it down, looks like 5. So that's -5. I love it. It's pretty cool because you know for sure that you are correct and you can press submit. That's beautiful. I like those problems. Okay, and why are you thinking so long, Delta Math? Okay, gotcha. You're done. Stop thinking. Well, I may end this video if it's not going to stop thinking soon. So I just think I've given you some ideas, however, about how to work this program. I really like I don't know. I really like a lot. I love the way they have you do the transformations. I really think that's very helpful in terms of making sure you understand how the transformations work. But I will just give you some more extra practice. I'll post it, extra practice of just the ones like down here. So hopefully this helped you. Sorry, I got cut off there. I cut myself off. I just wanted to say hopefully it helped you, and please have a great weekend. See you next week.